All right, so if you look here at letter A, you want to first find the biggest exponent before you make any decisions. So this is indeed a cubic function. It doesn't matter if the 8x squared is first, biggest exponent wins. So because it is a positive 4 in front of an x cubed, it's going to resemble this picture. You're going to have an arrow pointing up on the right and down on the left. So you're going to set yourself up as x approaches infinity and as x approaches negative infinity. F of x approaches, f of x approaches. So you're telling me on the right side, the arrow points, and then you just tell me what it's doing. And then same thing down here. On the left side, the arrow points which way? So we can obviously see it's pointing up on the right and it's pointing down on the left. So that's how we write our end behavior. All right, letter B has a squared and a -2. So this is going to be a quadratic. The biggest exponent wins the game, but it is negative. So negative quadratics have frowny faces. So this would look kind of like that. And you can see I've already set this up because all I have to do is just tell what's happening on the right and what's happening on the left. And they're both pointing down, so they're going to both have negative infinity. Same thing for C. Before I even draw the picture, I might as well just do my setup. I have a right side, I have a left side, and I'm going to have two end behaviors. So all of this stuff is going to be in every single problem. So you look at your powers, you have a 4 and a 5, 5 wins. So we have a negative odd power or degree. So it's going to be almost like A, just backwards. So the left side points up and the right side points down. So this will flip-flop. On the right side, the arrow points down. On the left side, the arrow points up. So it's the same answer, just flip-flopped. And then letter D, go ahead and set up your presentation and then make your decision. This is degree 4, which is even, and it is positive. So it is going to look like a smiley face. And whoops, I have the wrong drawing there, so we're just going to hand draw this. All right, so it's going to resemble a smiley face, and obviously both ends point upwards. All right, so that's our little presentation on end behavior. It's not super complicated, just weird, the notation. This is going to be mathy, so we're actually going to use our math skills for these problems. So what you have here is a function, right? It's a polynomial of degree 3. And your job is to factor this. Now, the only thing that you know how to use when there's 4 terms is grouping. But if I break these in half and try to pull out a GCF, the parentheses are not going to match. So grouping's not going to work. So the question is, what do you do? We're actually going to use the graph of this. So if you typed this formula into Desmos and let it graph it for you, this is the picture that you would get. So this is the graph of this formula. You can actually take the x-intercepts or zeros or roots, whichever word you prefer, and use that to help you factor this. And here's how. You can see that we have 2 x-intercepts, one at -1, one at 2, and then we have a third one, but it's somewhere between 4 and 5. I don't know exactly though, so that's not really going to help me, but I do see that this one's at 2 and that one's at -1. I can actually use either of those. It does not matter if you want to use the 2 or if you want to use -1, it doesn't matter. And you're going to do some synthetic division. So I want you to take all your numbers here, put them inside your L, and then you take one of your x-intercepts and you're going to put it right outside. We're not changing the sign, we're just going to copy it. So I think I'm going to use 2 in my example because I like positive numbers more than I like negative numbers. And you see how I just kept it as 2. I did not write -2. So the x-intercept truly goes here. then I'm going to start my synthetic. We drop the 4, we multiply 4 times 2, and then we add. And then we multiply, and then we add. And one more time, we multiply, and then we add. And here's the good news when you have a graph. If you're using an x-intercept, you will always get 0 as your remainder. So that's a really good way to check if you're even doing it right, because if you get 0, that's a good sign. All right, we like that. So what we're going to do is we're going to put the letters back in our answer, but I also want you to tell me what the divisor is. So if there's a 2 out here, what would have been the divisor? It would be x minus 2. The rule is whatever the divisor is, you put the opposite sign here. So if I see positive 2, it must have said x minus 2. So that's something that's new. This you've done before. You guys know that if you started as a cubed, your answer will start as a squared. So all of them go down. Now I know you guys are not fond of t's, so I did change everything to x's. And then you just look in your parentheses and you ask yourself, can I go further? And we have a classic long x method that we can do. So we're going to run through that real quick. Just don't forget, you have to multiply 4 and 17, so the top's actually negative 68. If we play around on our calculators, or if we're observant, negative 17 and positive 4 are actually the mystery numbers that make this work. Right? So because we cannot cheat, instead of just writing this and saying I'm done, we would have to divide by this 4. And then we're just going to slide this 4 up, but this one will become a 1, and x method is done. So I'm going to replace my trinomial with its factored form and just bring down my x minus 2, and that's my answer. So it's pretty normal that when you have a cubic function, you have 3 sets of parentheses. That's going to happen most of the time to you. So we have another one to try. All right, here is another cubic function. If I tried to group it, the parentheses would not match, so I'm stuck. All right, so when I look at this picture, I can see there are 3 x-intercepts. However, these guys right here, those look like decimals. They're somewhere between, like this one is between 0 and 1. This one is between 2 and 3. So I'm not sure exactly where those are, but I can see this one is at negative 3 exactly. So that's the number that I'm going to use in my synthetic. Now I am going to go through my synthetic kind of quickly because you guys are not new to that. And you make sure you get that nice pretty 0. And then we're going to go to rewrite our answer. If it says minus 3, that means it was x plus 3. And all my powers go down by 1. And I can definitely try x method with this guy right here. Do a little playing on my calculator, and these are going to be the magic numbers that I get. And practicing that new slide and divide technique that I showed you there. So there's your mystery numbers. Got to divide them both by 8, right? And then we reduce. So this would really be 9/4. So slide the 4 up, and there's the 9. 1/2, slide the 2 up, there's the 1. My x method is now done. Bring down my x plus 3, and look at that, 3 sets of parentheses, just like that. So because this is using 2 skills that you've already practiced a lot for me, I'm going to ask you to try the last one on your own. You actually have 2 x-intercepts that you can use. So do your synthetic, make sure you get that 0 as your remainder, and then you're going to finish it up with the x method. All right, go ahead and try it, pause, and then when you're ready, unpause. All right, you guys, so either you used 2, which in that case you're red, or you used 4, which in that case you're blue, so you can check your work. But obviously if you got, 0 for your remainder, you're doing it right. If you found the numbers to make your X method work, you're doing it right, all that fun stuff. So no matter what, you should end up with the same 3 parentheses.